Hi everyone, in today's video we're going to go over a signals and systems problem. So here on the screen, the problem reads, find the even and odd parts of the following function. So the function is given to us as a graph, and we're asked to break this down into its even and odd parts. So to start, the first thing we'll do is recall that we want to represent this function x of t as the sum of two parts, the even part and the odd part. And now recall that the formulas for extracting the even part and the odd parts from a given function are given as follows. So for the even part, you sum your function with its reflected signal, and then you divide the resulting waveform by 2. And then to extract the odd part of your given function x of t, you'll subtract the reflection of the original signal from the original signal, and then you will divide the resulting waveform by 2. And just a quick note, when I say the reflected waveform, recall that x of t, recall that x of negative t is the reflection of x of t over the line x equals 0, or the y-axis. Alright. So the way we'll start this is by first parameterizing our graph as a piecewise function. So here we have the original question, and so we've broken this up into individual pieces. So the length, the pieces from t equal -2 to -1, -1 to 0, and from 0 to 1. And so you see here that we've noted that from -2 to -1, for example, the value of x of t is 2. Between -1 and 0, this line here is given by the straight line minus 2t plus 0. Plus 0 is the y-intercept of 0. Minus 2t, the minus 2 is the slope. So as you go from -1 to 0, the height drops by 2. So that's just a straight line formula there, minus 2t plus 0. I left out the 0. And then between 0 and 1 on the t-axis, the value of x of t there is -1. So before we move on any further, let's take a quick recap of our even and odd decompositions. You'll notice that to extract the even and odd parts, we need two things. We need the function, it's x of t, and its reflection over the y-axis given by x of -t. So far, in equation form, we've determined x of t. To get x of -t, all we'll do is plug in -t into this entire equation. So we have that down here. So let me zoom out a little bit. All you'll see that's happened as you look from the top toward the bottom is that everywhere we see t, we've replaced it with -t. So a t was originally up here, we replaced it with a -t down here. And everywhere else we see a t, we also replace it with a -t. So just one final example, this -2t, you replace t with -t, it becomes 2t. So after this, we'll just do some simplifications of our equalities on the right-hand side of this equation. Specifically, we're going to multiply each of these equalities by -1, just to make it so that we have t by itself and not -t. So all that's happening as we go from the left to the right is we're simplifying the equalities. And now remember that when we multiply by -1, all of the signs flip. So on the left side, they were all less than. When you multiply by -1, they'll now be greater than. And so if you just think about these, you'll see that we've preserved this relationship. Nothing has changed, it's still true. So now as we move to the next part, all I'm doing now is reversing this inequality. So on the left side, we said t between 1 and 2. So there's 1, there's 2, and t is between 1 and 2. It's you see that t is less than 2, therefore t should be left before 2, and t is greater than 1, therefore t, as I've drawn it here, comes after the 1. So you'll notice that just by writing it a little differently, I still, just like before, I preserve the meaning of that equality, or inequality rather. And then the final step that I'll do as I move from here to here is I'm just going to rearrange each of these rows. So for example, -1, the t from -1 to 0 should be on the top. So I've written that up here. The -1 that was originally there, I've rewritten back up here. This 2t, or rather values of t from 0 to 1 stays in the middle, and the expression when t is in this range is still 2t, just like before. And then t from the range 1 to 2 goes on the bottom, and the value of x of t in this range is 2, just like before. So again, I've not changed anything. Everything in this equation is preserved. I've just written it in a more friendly and readable manner. And you'll notice that now as you read from top to bottom, the values of t are going from left to right. So from -1 to 0, from 0 to 1, from 1 to 2, etc. The next step I'll do is just to simplify everything that I've written. So we have an expression, or rather an equation for x of t, a piecewise equation. We also have a piecewise equation for x of -t. And the next thing I'll do is I'm actually just going to put everything here into a graph. In the first row of this table, you'll have t values for t. So t from -2 to -1, from -1 to 0, from 0 to 1, from 1 to 2, etc. And then you'll notice that in this first column, I list out x of t and x of -t. So we'll just focus on these first two rows for now. and show you how I populated this table. So for this first box here, I want to know what the value of x of t is when t is between -2 and -1. So all I do is I scroll over here, and I look for x of t when t is between -2 and -1, and I see that the value of x of t at that point is 2. And similarly, from -1 to 0, it's -2t. From 0 to 1, it's -1. And then from 1 to 2, since it's not defined in this piecewise function, I can put a 0 there, and that preserves this equation and doesn't change anything about it. And then now I've gone through how I populate this first row. We'll go through the second row now. So same thing, from -2 to -1, what is the value of x of -t? Well, in this piecewise function, I don't give a value for x of -t between -2 and -1 for values of t. So I'll put a 0 there, just like I did for x of t for t values between 1 and 2. And then from t values between -1 and 0, I know that x of -t is -1, so there's a -1, and then etc. You have the 2t and the 2, etc. So now we're done with these equations, and we now have everything in a nice table. So we'll just focus on the table now. Recall for a second, before we continue, that the expression or equation for extracting the even and odd parts of a given signal or function, you'll have to sum the original with the reflection, and you'll have to subtract the reflection from the original. So that's all I'm doing down here. I'm ignoring this factor of 1/2 for now because it doesn't really matter. So here we are. We have the sum of the original and the reflection, and then we also have the difference between the original and the reflection. So you'll see that for this row, all I do is I add the two items above it. 2 plus 0 is 0, and then you'll see that it's the same thing for all these other columns. -2t minus 1 is -2t minus 1, -1 plus 2t is 2t minus 1, 0 plus 2 is 2. So we filled up this column by following the expression in this, we filled up this row by following the expression in this column here. And then for the final row, we'll just follow this expression again. This time we'll subtract what's in the second row from what's in the first row. So 2 minus 0 is 2, -2t minus 1 is -2t plus 1, etc., etc. So at this point, you filled out your whole table. And then you can actually plot out the third row and the fourth row. So everything that we just did in this table, there's a graphical way of doing it. You'll have you'll draw out your x of t, which is given, and then you'll plot out your x of -t, which you've listed in this table. So you know the values of x of -t for all these values of t here, and that will result in a plot that looks like this graph on the bottom here. And you'll notice that it is indeed, this x of -t is indeed just the reflected version of x of t over the y-intercept, or the y-axis, or x equals 0, this line here. So this matches our intuition, and then you can sum them up, and you can plot out what's here. You can plot out x of t plus x of -t for all these values of t, and that will result in this graph on the bottom here. And another way you can do this without having to use the table is to actually just look at these two plots above and sum them up. So, for example, in between these two blue lines here, you have 2 plus 0, therefore it's 2. And then between this blue line and the the y-axis, you have this line here, and then you're going to shift that line down by 1 because you're adding this value of -1 to it. So again, you still have that line that goes downward, but instead of starting from a y value of 2, you start from 1 now because you shifted it down. So you can see that you can work this in two ways. You can either go with the table, or you can plot this out and do it visually. And so on the left side, you have x of t plus x of -t. You have that drawn there. On the right side, you have x of t minus x of -t. So these are the plots of the third and fourth row in this table here. And then the takeaway is, recall that if you were to multiply this by 1/2, you would get the even part of the function, the even decomposition of the original function. If you were to multiply this by 1/2, you would have the odd part. And you'll see, so again, we're ignoring the 1/2 for now, but you can easily see for now that this plot is in fact even. So recall that even means that it's symmetric about the y-axis. And you can see that this on the right is in fact odd. Recall that odd means that it's reflected over the line y equals x. So to finish up with this problem, all we'll do is include that factor of 1/2, and we can write our output expression for the even part of x of t and the odd part of x of t as piecewise functions. And all we need to do is, again, recall that we already have, for example, x of t plus x of -t in the third row of this table, and we're just going to multiply each of these values now by 1/2. So you'll see all these 1/2 factors of 1/2 here, and then you'll see that the second factor is exactly what we have in the table. So the 2 matches this 2, -2t minus 1 comes from right here in the table, 2t minus 1 comes from there, etc. And you'll again notice I have the piecewise, so this value is true only for t values between -2 and -1, so that comes from the header row of our table. And you do the exact same thing for the odd part, and that'll result in this piecewise function. And at this point, you're just about done with the problem. If you want to plot this out, what you can do is you can just take these plots here, and remember that the difference now is you're multiplying. So instead of plotting just x of t plus x of -t, you're multiplying by a factor of 1/2. You're doing the same thing on the right side, also multiplying by a factor of 1/2. So all you need to do now is really you just need to divide the y-axis by 2. So originally this here was 1, this was 2. Since we're shrinking it by 1/2, this fact here, that 2 gets divided down by 2, becomes a 1. That 1 gets divided by 2, becomes a 1/2, etc. And it's the exact same story on this side here for the I part of this function. Okay, thanks.